On the morning of February 1st, 2003, Space Shuttle Columbia broke apart during reentry, resulting in the total loss of its 7-member crew. The disaster resulted from two intersecting forces: a severe physical breach of the spacecraft and systematic organizational blindness. By examining the investigation's findings, we can map the specific safety protocols and cultural overhauls that dictate modern aerospace standards today. This image shows the massive scale of the shuttle's external fuel tank. Exactly 82 seconds after liftoff, a piece of foam insulation roughly the size of a suitcase broke away from it. This 3D schematic illustrates the point of impact. The foam struck the left wing's leading edge, punching a 9-inch hole through the carbon composite panels. This gap allowed 3,000-degree heat to bypass the heat shield entirely during reentry. The descent timeline overlay maps a rapid degradation over 6 minutes. Following the first abnormal heat readings at 8:53 a.m., total structural collapse and telemetry loss occurred at an altitude of 39 miles, while traveling 12,500 miles per hour. Once the thermal barrier was compromised during the launch sequence, surviving the extreme friction of the descent was physically impossible. The Columbia Accident Investigation Board identified the root cause as a human one. Their report explicitly cited an organizational failure and a refusal by leadership to hear hard truths. Engineers at consoles like these spotted the foam strike on the launch footage immediately. They flagged the risk and requested further imagery, but management ignored the warnings to protect the mission schedule. When leadership treats safety personnel and their data as obstacles to efficiency, the systems designed to keep crews alive degrade and fail. To resume flights, NASA mandated strict physical countermeasures, implementing advanced foam mitigation and requiring exhaustive in-orbit inspections of the heat shield before any shuttle was ever cleared to return home. This comparison table details the structural communication overhaul. Pre-2003 systems allowed managers to suppress safety concerns. Post-2003 protocols force a safety-driven model, mandating formal engineer feedback loops that leadership is required to address. Continuous structural risk assessment dictates that frontline technical data must flatten traditional management hierarchies. Looking at the Columbia Memorial, it stands as a permanent reminder of the industry's new baseline: absolute zero tolerance for unverified structural risks. Human spaceflight requires that the technical authority of engineers always outranks the administrative pressure to maintain a launch schedule. As listed on this slide, modern aerospace safety relies on continuous inspection, flattened reporting structures, and strict debris verification. The 7 astronauts aboard Columbia paid for these protocols with their lives, making adherence to them a permanent, non-negotiable obligation.